So here in this problem, we are being provided with an equation of a parabola. For this particular parabola, we need to find out the coordinates of its vertex and the focus. We need to find out the equation of the axis and the directrix and the length of its lattice rectum. Let us begin. So what we'll do? We'll begin by considering the given equation of the parabola. So here we have y squared minus 4y minus 4x plus 16 equals to 0. So what we'll do, we'll keep the quadratic terms of y. So that means we have y squared minus 4y. And we're going to transpose this third and the fourth term to the right hand side to get 4x minus 16. Our goal will be to convert y squared minus 4y into a perfect square by using the method of completing the square. So here we'll take y squared. We're going to rewrite 4y as 2 times y times 2. So this number 2 is going to tell us that we need to add the square of that number to the two terms. But this is an extra term that we are adding, so we need to subtract 2 squared from it as well. So this will be equals to 4x minus 16. So the first three terms, this is nothing but the expansion of y minus 2 whole square. Then minus 4 equals to 4x minus 16. So we get y minus 2 whole squared equals to 4x minus 12. Now what we'll do, we'll take 4 as the common factor on the right hand side. So 4 gets multiplied to x minus 3. So this is the equation of the parabola, although it is in the standard form, but the coordinates of the vertex has been shifted. So in order to find out the new position of the vertex, we are going to make a substitution here. In fact, we're going to do two substitutions. So here, let us suppose that x minus 3 be equals to x in uppercase and y minus 2, let this be y in uppercase as well. So that means what we have, initially we had the coordinate system in terms of x comma y. We are transforming it to a new coordinate system x comma y using these two substitution. That means the equation number 1 is now going to transform into y squared equals to 4x. Now as you can see, this is very much similar to the standard form of the parabola, y squared equals to 4ax. That means the value of a will be equals to 1. So what we've done, we have where we had the original equation of the parabola given in the old coordinate system x comma y, and we have transformed it to the new coordinate system. So this is x comma y in uppercase. So what we'll do, we'll consider the graph of the standard form of the parabola y squared equals to 4ax. From this graph, we'll consider a to be 1, and from with taking a value equals to 1, we can define the coordinates of the vertex, focus, the equation of the axis, directrix, and the length of the lattice rectum. And once we have those values, we'll be using these two transformation formulas to revert back to the original coordinate system. So let us begin. So here we have the graph of the parabola y squared equals to 4ax. This is a right-facing parabola with the coordinates of the vertex at the origin 0, 0. The coordinates of the focus of the parabola will be a, 0. And the line on which the vertex and the focus of the parabola lie is referred to as the axis of symmetry line. And since this axis of symmetry line is along the x-axis, so the equation of the symmetry line or the axis of symmetry line is y equals to 0. Now, on the axis of symmetry line, we are going to consider another point. Let's call it point B. And this point B is going to have the coordinates negative a, 0. That means the B is chosen in such a way such that V is the midpoint of B and F. Now, through this point B, we're going to pass another line which is going to be perpendicular to the axis of symmetry line. And this line is referred to as the directrix of the parabola since it is passing through the point B negative a, 0. So its equation is given by x equals to negative a, because we know any line which is parallel to the x-axis is having the form x equals to a. Fine. So in that case, a corresponds to the x coordinate of the point through which the line is passing. Then we have the lattice rectum. So that's a straight line that passes through the focus of the parabola, and it is perpendicular to the axis of symmetry with its endpoint being on the parabola. So here, if we choose a equals to 1, then we're going to get everything in terms of the parabola y squared equals to 4x. So let's begin with the new coordinate system. So in the new coordinate system, that means in x comma y, we have the vertex of the parabola given as 0, 0. So this means that the x value corresponds to 0 and the y value corresponds to 0. However, our goal will be to transform it back to the old or the original coordinate system x comma y. All we have to do is use the same equation x equals 0 and y equals to 0 But in place of x, we're going to use x minus 3. So here we have x minus 3 equals to 0. And for y equals to 0, in place of y, we're going to use y minus 2. So this will be equals to 0. So solving for x and y, we get the coordinates of the vertex in the old coordinate system. So that's going to be 3, 2. Let's now define the focus. So focus in the new coordinate system, that's a, 0. So a corresponds to 1. So we have 1, 0, meaning x value is 1 and the y value equals to 0. So x equals to 1 means x minus 3 equals to 1 and y equals to 0 means y minus 2 equals to 0. So this is going to give us the coordinates of the focus in the old coordinate system. So that's going to be 4, 2. Then we have the equation of the axis of symmetry line. The equation of the axis that's given by y equals to 0. So if it is y equals to 0 in the new coordinate system, then in the old coordinate system, y will get replaced with y minus 2. Y minus 2 equals to 0 is going to be the equation of the axis of symmetry line. Then we have the equation of the directrix. The directrix is given by the equation x equals to negative a. So here a corresponds to 1. So we have x equals to negative 1. Meaning in the old coordinate system, we have x minus 3 equals to negative 1. So solving for x, we get x equals to 3 minus 1. That's going to be 2. So x equals to 2 is going to be the equation of the directrix line. And then finally, we have the length of the lattice rectum of the parabola. The length of the lattice rectum will be equals to absolute value of 4 times a. Since a value is 1, so length of the lattice rectum will be 4 units, and this is going to be the same regardless of what coordinate system we choose. That means be the new system or the old system, the length of the lattice rectum remains fixed because that talks about the shape of the parabola. So we have successfully obtained the coordinates of the vertex of the parabola. We have the coordinates of the focus of the parabola. We have the equation of the axis. We have the equation of the directrix, and we have the length of the lattice rectum of the parabola. Whose equation is given by y minus 2 whole squared equals 4 times x minus 3.